lesson 6-6, Systems of Linear Inequalities. In the last lesson, we learned how to graph a linear inequality. And when we did so, we showed all of the solutions by shading the region, using a point on a graph to tell which region to shade. In a system of linear inequalities, we have two or more linear inequalities. They both have their own shaded region. The solution to that system is wherever those shaded regions match. Let me show you how to do this. So, graphing a system of linear inequalities. I have two linear inequalities right here. We're going to graph them both, shade their regions, and find where those regions kind of intersect. So first I want to look at this as a linear inequality, or linear equation. I'm going to make the less than sign an equal sign, 2x minus 3. If I graph that, I go minus 3 on the y-axis, slope of 2. And because it's a less than sign, I'm going to make a dashed line for my graph. Now to know what to shade, I'm going to put the point 0, 0, which is right here, into my equation. 0, 2 times 0 is 0, minus 3. 0 and negative 3, my inequality symbol is less than. 0 is not less than negative 3. Therefore, I must shade this region underneath my linear inequality. All right, my second linear inequality is not quite yet in y equals mx plus b form, so I'm going to write y equals, subtract the 2x over, negative 2x, plus 2. I go up 2 on the y-axis, slope of negative 2 over 1. And because it's a greater than sign, I'm going to again make a dotted line for my linear inequality. Putting this symbol back in, if I put 0, 0 in, I get 0 is greater than 2. Well, 0 is not greater than 2. So I'm going to shade everything on this side of my blue line. And as you can see, the two shaded regions, where they are have something in common was underneath the red line and above the blue line. So this green region is the solution to this system of inequalities. All right. We can combine our knowledge of linear equations with our knowledge of linear inequalities. When we graph the two, they are similar because we are still putting our linear inequalities into equations to graph the line. They differ because with inequalities, sometimes our line is solid, sometimes it's dotted, and we also shade regions to show solutions to inequalities, where in a linear equation, we either have an intersection or the lines are touching or not touching, where there would be no solution. All right, so problem 2, writing a system of inequalities from looking at a graph. This is kind of hard because there's a lot to look at. Now we have two lines and two shaded regions. The blue line, its shaded region is everything blue, the red line is everything shaded yellow, and what you see in green is the shaded region that these two lines share. It's their solution. So first I'm going to write a linear equation of the blue line. I have to look and see, well, my y-intercept is negative 1, and it looks like my slope is up 1 over 1, which is just x. Y equals x minus 1. All right, so if they shaded everything that's blue, that means they originally shaded everything up here. So 0, 0 must have been a solution. So if I put 0 in for both of these, I get 0 and negative 1. Well, 0, to make this true, is greater than negative 1. So I'm going to put my inequality back in. Y is greater than x minus 1. Now because the blue line is solid, this is going to be a greater than or equal to inequality symbol. So there is one of my inequalities in my system. Now we're going to look at the red line. Y equals y-intercept of positive 5 and a slope of down 1 over 2. Negative a half x. All right, so they shaded, that was a dotted line, so it's a less than or greater than sign. They shaded everything below, hence the yellow. So 0, 0 must have been a solution. I'm going to put that in. 0 and 5. For this to work, 0 is less than 5. So I'm going to put that in for my equal sign. Y is less than negative half x plus 5. So once these two lines were graphed, the green region is where their solution is. But these are the two inequalities of our system from looking at a graph. Take your time when doing problems like this. All right, you can model many real-world problems or situations by writing and graphing systems of linear inequalities. Some situations involve 3 or more restrictions, so you may have at least 3 inequalities. Let me show you an example. You are planning what to do after school. You can spend at most 6 hours daily playing basketball and doing homework. So the two combined, you can only spend 6 hours. I'm going to write an inequality for that. Basketball plus homework at most has to be less than or equal to 6 hours. We cannot go over that. All right, you want to spend less than 2 hours playing basketball. So basketball, you want to spend less than 2 hours. And you must spend at least 1.5 hours doing homework. Y has to be greater than or equal to 1.5. All right, those are our 3 inequalities. I'm going to transfer them to the next page. X plus y is less than or equal to 6. X is less than 2. And y is greater than or equal to 1.5. So we're going to graph all 3, shade all 3, and find the region in which they all have a solution. So first, x plus y is less than or equal to 6. I need to move x over, so this is going to be y equals negative x plus 6. 1, 2, 3, 4, 5, 6. Slope of negative 1. Because we're talking about time, I'm going to focus my graph just in the first quadrant. It's a solid line because I have a less than or equal to symbol. Now if I put 0, 0 in, 0 plus 0 is less than or equal to 6. 0 is less than or equal to 6. That is true. So I'm going to shade everything below my line. All right, next inequality. X is less than 2. Look at it as x equals 2. Here's x equals 2. It's going to be a dotted line or dashed at x equals 2. Putting 0 in, 0 is less than 2. This is also true, so I'm going to shade everything to the left of my line. All right, so now I can kind of ignore this shading because that wasn't in common with my x is less than 2. All right, one more inequality to graph. Y is greater than or equal to 1.5. 1.5 on my graph is right here. It's a solid line. Put 0 in. Y is not greater than 1.5, so I'm going to shade everything that doesn't include 0. I'm going to shade above my blue line. As you can see, the shaded region that these lines have in common is, let's find right here. I'm going to shade it in black. This little portion right here. That is the solution to our system of inequalities. Here's your lesson check. Please complete 1 through 3 and bring these problems to class.